So let's now move on to the next part of our discussion on vector algebra, vector directions. As mentioned in the previous video, it's very important that you take into account the direction of vectors whenever you do vector analysis. Thus, it's important for you to be able to tell or describe the direction of a vector. Now, we can describe the direction of vectors in many ways. We'll cover the more common ones in this video, particularly applicable for one-dimensional and two-dimensional vectors. First, we have the use of the Cartesian coordinates. In other words, the x-axis and the y-axis lines. So you have the x-axis, positive x-axis direction, negative x direction, and then you have the y-axis, positive y direction, and negative y directions. Suppose you have four vectors as shown in the figure. You have vector A, vector A, vector B, vector C, and vector D. To keep things simple, all of these vectors have the same magnitude, 5 meters, so that we can focus on the direction of the vectors. So first, let's take a look at vector A. Vector A, again, 5 meters in magnitude. Orientation of vector A, 30 degrees with respect to the positive x line. There are two sides to the positive x line. You have the above side and the below side. Where is the angle 30 degrees located? It's located on the above side of positive x. So we can say that the direction of vector A is 30 degrees above positive x. If we take the other angle, 90 degrees minus 30 degrees will give you 60 degrees. Now the 60-degree angle is with respect to the positive y direction. And we have two sides for the positive y direction. We have the right side rather, and the left side. Now where is the 60-degree angle located? It's located on the right side of positive y direction. So we can say the direction of A in this regard to be 60 degrees to the right of positive y. We can apply that notation for the other vectors. Say vector B, again, 5 meters magnitude. Vector B, the angle of orientation is 50 degrees and it is below the positive x direction or line. So the direction for vector B is 50 degrees below positive x. The complementary angle, the other angle is 90 degrees minus 50. That will give you 40 degrees. The 40-degree angle is with respect to the y-axis. In particular, it is on the right side of the negative y line. Thus, the direction for B, vector B, is also 40 degrees to the right of negative y. So, vector B, 5 meters, 50 degrees below positive x, and 5 meters, 40 degrees to the right of negative y. As for vector C, Vector C is heading directly towards the negative x direction. So we can simply say C is equal to 5 meters towards negative x. If it was heading towards positive y, therefore the direction will be towards positive x. Okay, if the direction is positive x. The same goes for positive y and negative y. Lastly, we have vector D, and the angle of orientation is 45 degrees, and it is above the negative x line. So the direction of D is 45 degrees above negative x. 90 minus 45 will also give you 45 degrees. This time with respect to the y-axis on the left side of positive y. So D direction for vector D is 45 degrees to the left of positive y. Another common way of describing the direction of vectors is by using the compass directions. This is particularly applicable for, say, maps and such. Using the same vectors as we had in the previous slide, in the previous example, we still have vector A, B, and C, and D, and same magnitude, 5 meters. But this time, instead of X and Y axis lines, you have north direction, east, south, and west directions. And we describe the direction of our vectors in terms of these 4 directions. Vector A, 30 degrees with respect to the east direction. The east direction, the east line, has 2 sides. You have the north side and the south side. Where is the angle 30 degrees located? It is located on the north side. So the direction of A is 30 degrees north of east. North side of the east direction. So north of east. The other angle, 60 degrees, is with respect to the north line, north direction. North line has 2 sides, the west side and the east side. Where is the 60 degrees located? The 60-degree angle located, it is located on the east side. So we can also say the direction of A to be 60 degrees east of north. East side of the north direction. So east of north. Applying the same convention with vector B. Vector B, angle of orientation is 50 degrees. And the 50-degree angle is on the south side of the east line. So the direction of B is 50 degrees south of east. The other angle, 40 degrees. You will recall 90 minus 50 will give you 40 degrees. This angle is on the east side of the south direction. So 40 degrees east of south. If we now take a look at vector C is heading directly towards the west direction. So we say that the direction of C is due west. So, due west. If it was heading in the north direction, due north. If heading in the east direction, due east. If heading in the south direction, due south. Next, we have vector D. Vector D, 45 degrees. If you look at the other angle, 45 degrees. So 45, 45. The direction of vector D is exactly in between north and west directions. So we can say vector D is due north-west. If the direction was directly between north and east, you have due northeast. Then you have due southeast and due southwest. So again, due northwest if exactly between north and west direction. Due northeast if exactly in between north and east direction. And due southeast if directly between south and east direction. And then you have southwest if directly between south and west direction. Of course, we can also apply the convention that we talked about with regards to vector A and vector B. We can say that vector D is 5 meters, 45 degrees north of west, or 5 meters, 45 degrees west of north. So you have the Cartesian coordinates for direction, and now you have the compass directions. Lastly, we have the polar coordinates, which simply put the direction, angle value, to denote the direction of the vector. There are different types of polar coordinates. One type of polar coordinates uses or follows the quadrant direction. So you have the horizontal axis, the vertical axis. You'll recall from your mathematics the quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. So that's counterclockwise direction. Starting on this line, this direction will be our reference direction. That will be the 0 degrees direction. 0 degrees, 90 degrees, 180 degrees, 270 degrees, then 360 degrees. Using these angles for direction, we can describe the direction of our vectors. So once again, using the same 4 vectors as we had before, vector A, B, C, and D. Vector A, with regards to the 0 direction, the angle of vector A is 30 degrees. So 5 meters, and the angle is 30 degrees. Counterclockwise is the positive direction. You can also look at it in terms of the clockwise direction. That will be the negative direction. So you have 0, negative 90, negative 180, negative 270 degrees, and then negative 360 degrees. In terms of the negative angle direction, vector A is 360 minus 30. That will leave you 330 degrees in the negative direction. So negative 330 degrees. Next, we have vector B. Vector B, the angle is 50 degrees in the clockwise direction. That's the negative angle direction, you will recall. So the angle direction of vector B is negative 50 degrees. So vector B is 5 meters and the angle is negative 50 degrees. In terms of the positive direction, 360 minus 50 gives you 310 degrees in the positive direction. So 90, 180, 270 plus 40, that will give you 310 degrees. So vector B is 5 meters and the angle is 310 degrees. Do the same for vector C and vector D. And that's it for now. We'll continue our discussion on vector algebra in the next video, wherein we look at the component method of doing vector addition. So thank you for watching.